The first problem requires that we use our knowledge of arithmetic operations. We are required to determine the exact value of the arithmetic expression that we have right there. The difficulty of the problem was reduced by placing the divide by 3 inside of the brackets. By so doing, we are not required to use our knowledge of the precedence of operation. Example, multiply and divide before we add and subtract. So we will proceed by squaring 12.3. We are required to square 12.3, and we are going to continue also by dividing 0.246 by 3. So the difficulty of the problem, a part of it is reduced somewhat because we have this placed in brackets. If we did not have the brackets right there, the expression would have meant the same thing. However, it would have been up to the students to realize that we could not subtract 0.246 from this that we have there and then divide by 3. Placing the bracket there is an indication already that we need to divide 0.246 by 3. However, it is not necessary for the bracket to have been included because we know that by the precedence of arithmetic operations, we would have been required to divide before we subtract. Let us continue. So we are going to square 12.3, and of course we are going to divide 0.246 by 3. And that's the result. Of course, we are going to finish up by performing the subtraction. So all we are going to do now is subtract 0.082 from 151.29. We are required now to write our answer correct to two significant figures. So we are going to write the expression correct to two significant figures. First, go to the second digit in order of significance. Two significant figures, so we are going to go to the second digit in order of significance. Right, that is the 5. That is the second digit in order of significance. And that is where we are going to focus. Of course, we are going to consult the very next digit in order of significance. That one. And we are going to examine to see if that figure or that digit is greater than or equal to 5. If it is greater than or equal to 5, we will add 1 to the second digit in order of significance. But of course, it is not equal to 5 and it is not greater than 5, so we do not add 1 to that digit. That is the second one in order of significance. So we are going to write the 5 as it is, that is without adding 1 to it, and of course we have the 1 also to be included right there. Now we have 151 and right here we have 15. There is no way 151 can be represented as 15 or should be represented as 15. Writing a number correct to a particular number of significant figures is an approximation. Therefore, our answer should be approximately equal to 151.208. In order that the value of the number is preserved, we are going to include place holding zeros. The point and its trailing zeros make no contribution to the value of the number. So this point and all of these zeros behind that follow the point, they do not contribute anything to the overall value of the number, and those may be left off. And our answer is therefore 150. In this particular problem, we are required to find the value of P. And P will be the value that we get, or the figure that we get after $40,000 has been depreciated by 12%. So we will depreciate $40,000 by 12%. So 12% will be lost, bringing the original cost from 100% to 88%. Right? So we are going to subtract that 12% from 100%, we get 88%. And of course, 88% is actually equal to 0.88. Then this 0.88 is multiplied by the original value of 40,000. And the result is 35,200. Of course, the value is actually $35,200, but in the problem, the dollar sign is already included, so it is P dollars. So it is the value of P that we want, and that is 35,200. In the second part of the problem, we are required to find the value of Q. That is, Q is the value or the rate of depreciation, and of course it is given as a percentage, right? And we have an initial value of 25,000 depreciating to 21,250. So we are going to write the new value as a fraction of the old. So we are going to put the new value of 21,250 as a fraction of 25,000. That turns out to be 0.85. And that fraction as a percentage will be 85%. This represents the new percentage value. The original being 100%, the percentage of depreciation is the difference between the two. So, if the value before the depreciation is 25,000, by working out the fraction, we get 0.85, and of course that is 85%. So, the new value is 85% of the old. Therefore, what percentage would have been lost? The percentage that would have been lost is going to be what? 100% minus 85%. It was 100% at first, and now it is down to 85%. Therefore, we know that it would have lost 15%. 100 minus 85, and that is equal to 15%. And of course, it is Q percent, so Q is equal to 15. We are now required to determine the value of the taxi after its value has been depreciated for 2 years. But here we have the figure after it has depreciated 1 year. So all we have to do is depreciate it by another year. So we have to cause the value to diminish by 0.88, or to depreciate by, or to lose 12%. Of course, to lose 12%, we need to multiply by 0.88 as we did before. So all we need to do is take this value that we have here and multiply by 0.88 again. So this will be the depreciation after 1 year, and after 2 we will take the value that we have after the first year and depreciate that by a further 12%. Of course, it means that we need to multiply this by 0.88 again. And there we have it. The value after the depreciation of the first year is used to determine the value of depreciation after the second year. Of course, by multiplying it by 0.88, which is the percentage written in a fractional form representing a depreciation by 12%. The answer is $30,976. We are required now to use the rates of exchange in determining the value of currencies. So, of course, we are going to use, for convenience, or we may say for a guide, use a table to assist us. It is not completely necessary, but we are just using that to help us. So, the rate is Guyanese $1 to US $0.01, which is of course 1 cent. We have the amount in Guyanese, which is 60,000 Guyanese dollars, and we need to convert that to US dollars. According to the figures that depict the rate in the table, the smaller figure is on the US side. Therefore, the conversion must reflect the same. Therefore, what we are saying is that if we look at these figures that we have in the header of the table, those that are representing the rate of exchange, we realize that a smaller figure is on this side. Therefore, if we are going to convert from 60,000 Guyanese dollars to US dollars, we realize that the figure that we are going to get on the US side must be less. So we multiply 60,000 by 0.01 and the result is $600. Now, most people are so mentally oriented to believe that in order to get a smaller figure, we have to divide. But do not forget that when we are multiplying by a fraction that is less than 1, the result is going to be smaller than the original figure. So when we multiply by a fraction that is less than 1, the result is going to be smaller than the original figure. And of course, we need to do another conversion, this time from EC to US, and the rate is going to be included in the table so that we can see and of course make a comparison. So we have the amount in US right there, $925. Of course, if we compare this, we have $1 on the EC side and of course 0.37 or 37 cents on the US side. Therefore, the figure that we have on this side is smaller than the figure that we have on this side. Or we may say that the figure that we have on this side is larger than the figure that we have on this side. Therefore, when we make our calculation, the figure that we are going to get on this side must be a larger figure if we are being consistent with what we have in the table. So how do we get a larger figure? 925 divided by 0.37, and that gives 2,500. Of course, again, we may be thinking just off the top of our heads that if we are going to be dividing, the figure should be smaller. But do not forget that when we are dividing by a fraction that is less than 1, the result is a larger figure. So the result is going to be larger when we are dividing by a fraction that is less than 1. So the result is going to be larger when we are dividing by a fraction that is less than 1. when we are dividing by a fraction that is less than 1. And of course, there's no harm in getting the incorrect answer. Say for argument's sake, we want a larger figure on this side, and you just go straight ahead and multiply by 0.37. That happens all the time. But take a good look at the result that you get. According to the information that we have up here, the number that we have over on the EC side should always be a larger figure. So if you go through a process and you get a smaller figure, it means that something is wrong. The most likely or the most sensible thing to do is to use the opposite operation and get your desirable result and move merrily along. So if you do something wrong, just correct it and move on. It is very important for you, however, to realize when something is wrong. So you just don't keep going, and you are totally oblivious of whether the answer that you get is wrong or right. As long as you keep that presence of mind, you will do well on the examination. We are required to simplify the algebraic expression that we have right there. So we are going to simplify that one. So let us begin the simplification of the expression by applying a principle that we learned in primary school, that of finding the common denominator. So we are going to find the common denominator first. Right. So this will be the LCM of the two denominators. The LCM of 3 and 5 is 15. So we are going to say what? 3 into 15 is 5. And we are going to say what? 5 times x minus 3. So that will go right there. And do not forget that the negative sign belongs to the entire second fraction. So this fraction, the negative sign belongs to the entire fraction. Some students will do things like this and get the incorrect thing. 5 into 15 is 3. And they have a negative sign right there. They say 3 times x is 3x. And they say 3 times negative 2 is negative 6. But to have a negative 6 there is incorrect, as we shall see in a short while. So we say 5 into 15 is 3, and we take the 3 to multiply the x minus 2. Good. Then continue our simplification process by expanding the brackets. So 5 times x is 5x, and 5 times negative 3 is negative 15. Then of course negative 3 times x is negative 3x. And of course, what do we know? Negative multiplied by negative. So instead of a negative 6, we should have a positive 6. And continuing, we are going to put the like terms together. 5x minus 3x is equal to 2x. And of course, negative 15 plus 6 is negative 9. We are required to factorize this expression, and of course we are going to be using the most basic rule that we use in factorization. So the common factor is x. Of course, basic factorization, take the common factor, divide each term by the common factor, and that's all there is to it. So x is the common factor. X can go into x squared and go into negative 5x. So we say what? X into x squared is x, and x into 5x is 5. So we have x minus 5. Do not forget our good friend, the difference of two squares. The solution of this problem depends on our ability to spot, of course, the difference of two squares. And we recognize that we have a difference of two squares right there. The square root of x squared is x, and the square root of 18 is 9. In one bracket we have x plus 9, and of course in the other bracket we have x minus 9. Now we have an algebraic fraction. I like this problem because this problem requires us to understand that we cannot just go ahead and start to say a squared will cancel with a squared and a will cancel with a and all of that. So that is going to be very horrible. That is disastrous if any student should attempt to solve that problem that way. When we have algebraic fraction, we cannot reduce the fraction unless we have what? Factors that are common to both numerator and denominator. We will therefore factorize the numerator and of course factorize the denominator. The common factor in the numerator is a. So a into a squared is a and a into 4a is 4. So the common factor goes there and of course the other factor goes right there. And of course this is a trinomial in which the coefficient of a squared is 1. So we may just write down the two factors of that one. But on what premise are we going to do that? The denominator is a trinomial. Find the two numbers that multiply to give negative 4 and add to give 3. So these two numbers should multiply to give negative 4. And when we add them, we get 3. What are those two numbers? The two numbers are negative 1 and positive 4. We are going to have a minus 1 and a plus 4. Of course, if we have them in the reverse order, a plus 4, a minus 1, there's no harm done, because the way or the order in which we multiply two numbers does not affect the product. So we have a plus 4, a minus 1. And we are going to reduce the fraction by a common factor that we can see right there to be a plus 4. So a plus 4 is common to both numerator and denominator. So let's go straight ahead. And of course, what we have left is a divided by a minus 1, and that's our answer. In this particular case, we are required to solve a pair of simultaneous equations. And of course, the pair of simultaneous equation is based on information that is given. I can see that for the last few years or so, the CSEC examination has been giving simultaneous equation in an applied form, or what we call worded form, or a worded problem. The statement says 2 cassettes and 3 CDs cost $175, while 4 cassettes and 1 CD cost $125. So, what do we do? The cost of all the cassettes will be equal to the product of the cost, and the cost is X, and the number of them. So we are going to multiply the cost by the number of them. And of course, we are going to do the same thing with the CD. We're going to multiply the what? The cost of the CDs by the number of them. And what do we see? We have 2 cassettes to be multiplied by X. And then we have what? 3 CDs to be multiplied by Y. The number times the cost. The number times the cost. The total will be 175. The next equation may be formed on a similar argument, that we multiply the cost of the cassettes by the number of them and the cost of the CDs by the number of them. This time we have what? 4 cassettes and 1 CD. So it is going to be 4 multiplied by X and 1 multiplied by y. And then the sum will be $125. And there we have our two equations. What are we going to do next? Well, if it is required, we will solve the two equations. And of course, we're going to solve them simultaneously. We realize that we have 3y here, while we have y here. So, all we need to do is just multiply this y by 3, and we will have 3y here and there. So, multiplying equation 2 by 3 will cause the coefficients of the y's to be the same. So, multiply this one by 3, we get 12x. Multiply this by 3, we get 3y. And of course, multiplying 125 by 3, we get 375. And all of this to ensure that the coefficients of the y's are the same. So now that they are the same, what do? We may subtract equation 1 from 3 or equation 3 from equation 1. That will cause the y's to be eliminated as 3y minus 3y is equal to 0. However, to avoid the negatives, we are going to use this one. So we're going to say 12x minus 2x, and then of course 375 minus 125. And of course our figures will all be positive if we subtract equation 1 from equation 3. Right. Students might want to do that, may want to take an approach that avoid using the negative. Of course, we know that people who are using Richard James mathematics resources are very skillful on manipulating positive and negative numbers. But why put ourselves through it if we don't have to? So we avoid the negatives in this particular case by subtracting equation 1 from equation 3. Solving that simple linear equation, we are going to divide by 10. So we get x is equal to 20. So the cost of one cassette, which is what we require, is equal to $20. It is not a matter of solving the entire equation. It's a matter of what? Giving the examiners exactly what they want. They want, in this particular case, the cost of one cassette. And there we have it, $20. Here we have a quadrilateral that is divided into two isosceles triangles. We are going to be required to find certain angles. So the angles that we are required to find are angle LNK. That is one that we are required to find. Angle LNK. The middle letter is where the angle is located. So if we are going to find LNK, then the angle is what? Located at N. So that is the angle that we want to find. Now, what we have here is an isosceles triangle. So we have an isosceles triangle. Triangle LNK is an isosceles triangle with the two equal angles opposite to the equal sides. So LNK is therefore equal to 40 degrees. The two equal sides are this one and this one. That is why they are marked like that, because they are equal in length. So this angle that we have right here is opposite to this one. And this angle, which is LNK, is opposite to this one. So the two equal angles are opposite to the two equal sides. So we are sure that LNK is also equal to 40 degrees. Right, we just include it there in a small form in order that we may be able to recall it easily if it is required in the problem. The other angle in triangle LNK is equal to 180 degrees minus 2 times 40. Of course, all the angles in a triangle add to give 180 degrees. So the other angle, now this big angle that we have right here is 140 degrees. It is not the angle here that is 140 degrees. It's the one all the way around here that is 140 degrees. Right? And we are required to find, in this case, angle NLM. This one. NLM. So the angle is located at L. The entire big angle is 140 degrees. So we are trying to find now the angle here. This angle. And of course, this angle is inside of the isosceles triangle, in which the two equal angles are equal to 40 degrees. When the angles of a triangle are added, we get 180 degrees. So all we need to do is take away these two from 180, and we will get the size of the angle that we have right here. So no problem with that. The angle that we have right here is 180 minus 2 times 40, and of course 2 times 40 is 80. So 180 minus 80 is equal to 100. So 100 degrees. Of course, this one that comes right here is 100 degrees. But the one that we are required to find is this one. The large angle shown is 140 degrees. Therefore, angle NLM is equal to 140 minus 100, which is equal to 40 degrees. Do we put it right there also? Yes, it is also included right there. So NLM is 40 degrees. And we are required to find KNM. We are required to find KNM. So KNM. We are required to find this big angle that we have right there. KNM. Of course, a part of it is already known, which is 40 degrees. So our duty is to find this part. And what do we know? The other triangle is also isosceles with the two unknown angles equal. So we have 40 degrees right here. And of course, these are the two equal angles. This one at M and this one right here are the two equal angles. But we do not know what they are equal to. But they are easy to find because we have an isosceles triangle. Those two angles are equal, and this one is equal to 40 degrees. So all we need to do is subtract this 40 from 180 degrees, as we have it right here. 180 minus 40 is equal to 140 degrees. Therefore, these two angles will add to give 140 degrees. So each one is equal to 70 degrees. So the entire angle that we need to find is that one. KMN is the sum of the two angles, 70 degrees and 40 degrees, and we get 110 degrees. So KNM is 110 degrees. This problem requires that we complete the Venn diagram and also do our little calculation as required. So we are going to place the information in the intersection of the two sets first. But before doing that, we have 39 students in a survey. 18 can ride a bicycle, 15 can drive a car. 8 can ride a bicycle and drive a car, and 3x can do neither. So we are going to put that information in the Venn diagram. Of course, x can do both. 18 can ride a bicycle, but x of them are in the intersection. The number unique to b will therefore be the rest of them. So 18 can ride a bicycle, and of course, x is already included in the intersection. So the rest of them, which is 18 minus x, is going to be unique to the set B. The next part is analogous to what we have just said. So we have 15 can drive a car, and we have X of them already in the intersection. So 15 minus X is going to be those unique to the set C. Those who can do neither, that means they do not belong to set B, they do not belong to set C, but they are part of the survey, so they are placed inside of the Venn diagram, but not in any of the circles that we have there. And those are represented by 3x. So the number, the total number in the survey will be the sum of all the numbers in the different sections. And of course, we know that it is equal to 39 already from the statement of the problem. Now, we are required to find the value of x. So if we are required to find the value of x, all we need to do is to solve this equation. Our first step is to separate the unknowns from the knowns. So all terms that contain x will be on the left hand side, and all that contain the numbers, pure numbers, will be on the right hand side. Transposing this positive 15 will be subtracted on the right hand side, and of course this positive 18 will be subtracted on the right hand side, and we are going to put all those x's together and we get 2x. 2x is equal to 6. Dividing by 2, we get x is equal to 3. We are required in this problem to construct, right? So we are going to do a construction using a ruler, a pencil, and a pair of compasses. Construct the triangle ABC, in which AB is equal to 8 centimeters, angle BAC is 60 degrees, and AC is equal to 5 centimeters. So first, we are going to draw the line AB, which is 8 centimeters in length. Right, so we use our ruler. Notice that when we are using our ruler, the point of the pencil is not placed at the end of the ruler, because the ruler is so designed that the 0 position is a little bit in from the end of the ruler, like right there. So this is where we are going to begin, as we can see right there, and we are going to draw our first line, which is 8 centimeters in length. And that line is AB. Now we are going to construct the angle BAC, which is equal to 60 degrees. And of course, we have 3 letters BAC. That means the angle is at the middle letter, which is at A. So the angle is at A, 60 degrees. We are going to construct that 60 degrees angle. So in constructing that angle, we put the point of the compass at A, and we are going to make 2 arcs as shown. Those are our 2 arcs. Of course, we are going to remove the point to where the arc crosses the line AB. And of course, without changing the compass, we make another arc. So, do not forget that the line that goes from A to C must be 5 centimeters long. Take our ruler and we draw a line which is 5 centimeters long. So 5 centimeters, that's it. There goes our ruler. We may then label the point C, and of course we are going to complete the triangle by joining B to C. measure the length of the side BC. Use our ruler again and we measure. As we can see, it goes from the 0 centimeter mark all the way to the 70. So we are sure that, of course, the 70 is given in millimeters, so we know that it's 7 centimeters. So 7 centimeters. The perimeter of a triangle is the sum of all of its sides. So we are going to find the perimeter by adding the sides, and we get 20 centimeters. Before attempting to solve the next problem, let us investigate the fundamental principles on which it is based. And what is the next problem? We are next required to draw the line CD, which is perpendicular to AB and meets AB at D. So we need to draw a line all the way here, but it must be perpendicular to the line AB. And where they meet, that is the line that comes from here to there, is going to be the point D. But we are going to take a look at the principles involved in doing that, so we are sure that what they really want us to do, we are able to do it. So, before attempting to solve the next problem, let us investigate the fundamental principles on which it is based. The principle has its foundation in a kite that is set on its side. So we are going to, well, it is a kite, of course, but we are going to put the kite on its side so we can see how our construct is related to the kite. So let us do that. So we are going to draw the kite first, and of course, according to the Oxford Dictionary, a kite is a quadrilateral that has two pairs of equal adjacent sides and is symmetrical only about one diagonal. So it is going to be symmetrical about one diagonal. One diagonal goes like this, and the other one goes like this. So this is the one diagonal that it is symmetrical about. So we put in our two diagonals, right? So this one is the one that it is symmetrical about, right? And this is the other one. It is not symmetrical about that one, but this is the one that we are intending to draw. And of course, what do we notice? We notice that this diagonal is at right angle to this one. By sight, it is obvious which two sides are equal. Let us put the kite on its side and discuss the relationship to our construct. So there is the kite on its side. So let us label the diagram with the same configuration of our previous construct. So we have a triangle A, B, C, right? That is our triangle A, B, C. It is not exactly like this, but we can make an analogy between the two of them. The next diagram will show the parts of the kite that are related to the diagram that we have constructed. Right. So the diagram that we have constructed is a triangle that is like this, A, B, C. Part D requires to construct the perpendicular from C to the line AB. That is what the construct or the statement of the problem requires. It requires that we draw a perpendicular line from C to meet AB. And of course, that point where it meets the line AB is D. It is a part of the entire diagonal of the kite. Right. So notice that this here, come down to here, is the same line. But this line is the entire diagonal of the kite. So it is the entire diagonal of the kite that we have right there. To construct it, we need to reproduce the distance AC on the other side of the kite. That is what we need to do. So in order to draw this line successfully, we need to complete the kite. in order to complete the kite, we need to take AC and reproduce it here, which is the same length. So AC, the same length as AC, is going to be reproduced right here, like that. And BC will also have to be reproduced. Alright, so what we have is a triangle, but what we want to reproduce the kite, of which the triangle is a part of it, and that is done by reproduce AC on that side like that, and also reproduce BC on the other side. So let us do the same on the other diagram. On the other slide, we will show the constructs that are necessary to do this. So we are going to produce AC on the other side. So what are we going to do now? Put the point of the compass at A and open it with the pencil at C. And then we are going to make an arc on the lower side of the triangle. So we are going to open the compass from A to C with the point at A. Then we make an arc on the lower side of the triangle like that. And then we move the point of the compass to B. Move the point of the compass to B. Open the pair of compasses until the pencil is at C. Then we make another arc to cross the first one as we have right there. Good. Then we are sure now that we have AC here, that we have here reproduced in length right there, and of course BC reproduced in length right there. So we still have the frame of the kite. So the line from C to the intersection of the arcs will be the other diagonal of the kite, but we are not really drawing the kite because it is not a requirement of the problem. The requirement of the problem is that we understand that it is the frame of the kite that we are going to manipulate in order to get that point D in such a way that CD is perpendicular to AD. So we are not required to draw the kite. We are required to understand it is the frame of the kite that we need to manipulate in order to get that. So what we have done is we have produced AC on this side, produced BC on this side. So that we have done. And we know that in our mind we have the frame of the kite. So what we are going to do now is to draw the next diagonal of the kite, because this is one diagonal of the kite and then this is the other diagonal of the kite. But it is only required that we draw the line from C to D. So that is what we will do. The point D is the intersection of the diagonals, so that is where D is. So we may draw the line CD as required, and that's all there is to it. It can be demonstrated that the construct was the frame of the kite. We can do that. It's not necessary to do it. As a matter of fact, we would not include that in an examination paper. But we are just showing for the understanding of the students that it is the frame of the kite that we are manipulating. Measure the line segment CD. So we are going to measure the line segment CD, and that turns out to be, as we can see right there, approximately, let's see, 1, 2, 3, 4.4, 4.3, thereabout centimeters. So we have that. CD is equal to 4.3 centimeters. The area of any triangle may be found by taking half of the product of any two of its sides and multiplying the result by the sine of the angle that the two sides form. And of course, if they are known, if the two sides are known. So let us do that. AB is equal to 8 centimeters and AC is equal to 5 centimeters. Right. The angle CAB is 60 degrees. Good. There we have two sides of a triangle and the angle that they form. A is equal to a half of the product of the two sides multiplied by sine of the angle that the two sides form. And the result is 17.3 centimeters. The area as calculated is dependent on the most precise construction of the triangle, because the sides 5 centimeters and 8 centimeters, and of course the angle 60 degrees were given. They were not necessarily drawn with 100% accuracy. Therefore, the area as calculated is what it should have been, but not necessarily what it really is. Let us make use of the dimensions that are actually in the diagram. So the base of the triangle is 8 centimeters, and we know that already. The perpendicular height we measured, so that was we measured that to be what? 4.3 centimeters. So we have the base 8 centimeters and the perpendicular height 4.3 centimeters. So we are going to use the formula area is equal to a half base times height. So A is equal to a half times 8 times 4.3. And that turns out to be 17.2 centimeters. And that is what we really should have had instead of using half AB sine C. We are required to find the values of A and B which define the domain of the graph. The domain of the graph is the set of values of x for which the graph is drawn. The graph begins with the lowest value of x equals -2 and ends at x is equal to 4, and that is going to be shown right there. So it starts where x is equal to -2 and ends at 4. So the values A and B is x is equal to -2 and B is equal to 4. We are going to determine the values of x where f of x is equal to 0. So the values of x where f of x is equal to 0 are the points where f of x crosses the x-axis. So where f of x is equal to 0, of course, this is our f of x axis. F of x is equal to 0 along this line, which is the x-axis. So we are going to find and use our graph to determine the values of x for which f of x is equal to 0. We are going to find the values of x for which the graph crosses the x-axis. And there we have them, -1 and 3. So x is equal to -1 and x is equal to 3. C requires us to determine the coordinates of the minimum point on the graph. That is the minimum point on the graph. We can trace this to the x value of 1 and the f of x or y value of -4. So the coordinates will be 1 for the x and -4 for the f of x. Find whole number values of x for which x squared minus 2x minus 3 is less than 1. So of course, if we are going to determine where x squared minus 2x minus 3 is less than 1, we are going to begin our analysis where it is equal to 1. So what are we going to do? Draw the line y is equal to 1 right there. And we are going to determine where the graph, as it is said, is less than 1 or below that line. So less than 1 means below that line. So it is below this line in this region. Right? In this region. So the specified region of the curve must be below the line. The arrows will show on the x-axis the points between which the value of x must lie. So the value of x must lie between this one right here and the one right there. Because about these points, we start to have the curve going below the line y is equal to 1. Right there. So those points, we have them as negative 1.5 and positive 3.5. So the values are actually between negative 1.5 and positive 3.5, and that is represented by set of x such that negative 1.5 is less than x is less than 3.5, and that of course is the most convenient format to write the answer. However, whole number values are required, so we are required to use whole number values. So the numbers that we are talking about, the value of x must be between negative 1.5 and positive 3.5. Therefore, the numbers, the whole numbers that we are going to be using must be between 1.5, negative 1.5 that is, and positive 3.5. So we are going to use those numbers. The set of x such that negative 1 is less than x is less than 3. We are going to find now, of course, we have the tangent drawn for us already. So we are going to find the gradient of the curve at x is equal to 2. And of course, we have the tangent already drawn at x is equal to 2. So let us find two convenient points, because if we are going to find the gradient of a line, we may do that by finding 2 points through which a line passes and use those 2 points along with the formula for the gradient in order to determine the gradient of the line. We have 2 points, right? So we are going to use those 2 points. The 2 points have coordinates 2 for the x and negative 3 for the y. So 2 negative 3, and this one has 4 for the x and 1 for the y. So 4 1. So we have 4 1 and 2 negative 3. And of course, we are going to use this formula. And what this formula is saying, we may say y2 minus y1 over x2 minus x1. Of course, it is equal to y1 minus y2 over x1 minus x2. So we may use any point as x1, y1, or as x2, y2, as long as we pay special attention to the order in which we are going to be subtracting the ordinates. So let us do that. So we have 1 minus negative 3, that is what we have there, over 4 minus 2. And we have 4 over 2, 4 to be divided by 2, which is equal to 2. So the gradient is equal to 2. A man walks x kilometers due north from point G to point H. He then walks x plus 7 kilometers due east from H to F. The distances along a straight line from G to F is 13 kilometers. The diagram below, not drawn to scale, shows the relative positions of G, H, and F. And the direction of north is also shown. So that's the diagram. And of course, what are we going to do with that diagram first? So the man walks x kilometers due north from G to H. So from G to H, north is x kilometers. He then walks x plus 7 due east from H to F. Alright, so it goes east. GF is 13 kilometers. Right. From the information on your diagram, write an equation in X which satisfies Pythagoras' theorem. Show that the equation can be simplified to give x squared plus 7x minus 60 is equal to 0. So, an expression of Pythagoras' theorem may be hypotenuse squared is equal to the square of one side, maybe side A, plus the square of side B. So we are going to use the situation that we have right there and transfer the information that we have into this formula that is a representation of Pythagoras' theorem. The hypotenuse is 13 kilometers. It goes there. Then the other two sides, one is x, so we square x and put it right there. And of course we have x plus 7 kilometers. That is the other one. So we have what? X plus 7 all squared. So let us continue. No problem. Squaring 13 gives 169. Squaring x gives x squared. But what will happen? Do not forget the expansion of the perfect square. Some students will do what? Only say x squared right there and square the 7 and then put it down. They forget that in the perfect square we have a middle term that is equal to 2 times the first times the second. So 2 times x, 2x times 7, 2 sevens 14, so we have 14x right there. We are going to transfer the entire expression on the right hand side. So we have this 169 transposed as a negative 169 on the right hand side. And of course we are going to put the x squares together. X squared plus x squared is 2x squared, and of course we are going to put these constants together also. 49 minus 169. See what we get? 2x squared, 14x, 49 minus 169 is negative 120. And then we realize that all of the terms of this equation may be divided by a common factor of 2. So 0 divided by 2 is 0, and the rest follows. 14 divided by 2 is 7. 120 divided by 2 is 60. In this particular case, we reverse the equation with 0 on the right hand side and all of the terms on the left hand side. And of course, it is not going to be far-fetched that they are going to ask us to solve the equation in order to determine the lengths of the sides of a triangle, if not just only the length of one side. We are going to solve this quadratic equation by factorization. We are going to determine the two numbers that will multiply to give negative 60 and will add to give positive 7. So we have one of those numbers 12 and the other negative 5. So we have x plus 12, x minus 5. So when we solve that, we have x is equal to negative 12 and x is equal to positive 5. Some students always ask, after I've taught them for the entire year, how comes you just put negative 12 there? How comes you put positive 5 there? When what we have here is plus 12 and a negative 5. We are saying that if two things multiply to give 0, this one is equal to 0, or this one is equal to 0. Or it may be that both of them are equal to 0. So, what we do, we solve x plus 12 is equal to 0. If x plus 12 is equal to 0, we transpose the 12, positive 12, to the other side. We have a negative 12. And of course, we are going to do the same for our negative 5. We will receive a positive 5 in that particular case. a negative value cannot be a distance. We cannot have a negative distance. Or a side of a triangle. We cannot have a negative side of a triangle. GH is therefore equal to 5 kilometers. And of course, there we have our original setup. So GH is 5 kilometers. We have one already. The other one is 13 kilometers. And of course, the bearing of F from G must be the angle that the north line makes with the line GF. The bearing of F from G must be the angle that the north line makes with the line GF. The angle must be measured in a clockwise direction. So in this particular case, we are going to determine the bearing of F from G. When we say from G, it means that the angle that represents the bearing is going to be at G. And of course, a bearing is measured in a clockwise direction beginning at north. So if this is our north line, this is G, the point that we have there. So the bearing of F from G is going to be this angle that we have right there. We have GH is 5 kilometers and GF is equal to 13 kilometers. So this is the angle that we are talking about. This side is adjacent to the angle and this side is the hypotenuse. The trig ratio that has adjacent and hypotenuse is the cosine. Therefore, we are going to be using cosine, the cosine trig ratio, in order to determine the value of that bearing. So cos of G is equal to 5 over 13. Therefore, G is equal to cos inverse of 5 over 13. And do not forget that a bearing must have 3 digits. So G is 067 degrees. And of course, we're going to write that right here. In this problem, we are going to complete the column. That is the midpoint column. That is what we're going to do first. In completing the column, we may make use of the fact that the values are the average of the lower and upper class limits. So in completing the column, we may make use of the fact that the values are the average of the lower and upper class limits. That is how we get the midpoint, or the midpoint values. The midpoint values are determined by adding the two limits and dividing the result by 2. We can do that each time, or we may make use of the sequence in which the numbers are increasing by 5 each time. So we realize that 7 plus 5 is 12, 12 plus 5 is 17, so 17 plus 5 is 22, and of course 22 plus 5 is 27, and 27 plus 5 is 32. So we could have done that, or 30 plus 34, that is equal to 64. Divide 64 by 2, we get 32. It is far more efficient in terms of time to make use of a pattern that we have inside of the table. So we are going to continue to find the mean, and we are going to do what? Find fx. So in order to find the mean, of course we know that the mean is equal to the summation of fx over the summation of f. So we are going to find the summation of fx. Cannot do that unless we know the values of fx. So let us find them. 2 times 7 is equal to 14. And of course 29 times 12, what is that equal to? 348. Then 17 times 37, a number ending with a 9, 629. 16 multiplied by 22. The next number will end with a 2, with an 8. And of course 2 times 32 is 64. Our next step is to find the sum of the numbers in the f and fx columns. Summation of f is 100 and summation of fx is 1785. Do not forget that the mean is given by the summation of fx divided by the summation of f. So we have 1785 to be divided by 100, and of course that gives 17.85 kilograms. We will draw the frequency polygon on the next slide. Only the frequency and the midpoint columns will be needed. So only two columns this time, the frequency column and the midpoint column, because of course in order to draw a frequency polygon we will plot the frequency against the midpoints. So draw the frequency polygon by plotting the frequency against the midpoint. So we have the midpoint is 7, so we go 7 along the horizontal axis and then up by 2, and of course our point will go right there. So we go 12 in the horizontal direction and up to 29. Then 17 and all the way up to 37. And all the way up to 22. And all the way up to 16. In the other one, 27 and all the way up to 14. Finally 32, and we'll go up to 2 in this particular case. We will complete the polygon by using straight line segments to join consecutive points. The polygon will touch the axis where the midpoint of the class that is previous to the first one would have been. So the one previous to 7, if we are going up by 5 each time, therefore we are going to go down by 5. So the one that will be previous to this will be at 2. So this one will be touching the axis roundabout where we have 2 marks, or we have 2 on the horizontal axis. And of course it will also touch the axis where the midpoint of the class subsequent to the last one would have been. So if we are going up by 5 each time, we are at 32 right here. It will touch the axis at 37. So roundabout right there, and then we have the frequency polygon completed. The frequency polygon cannot be completed unless we have straight line segments going down to the axes. It cannot be left hanging in the air at all. We need the total number of cows that gained 20 kilogram or more. So here we have 20 to 24 kilogram. Therefore 20 kilogram or more, we are going to have these 16 also included, because in this class we have those that gain from 20 to 24 kilogram. Of course we will include those in the other class. So the lower limit of the specified class is 20 kilogram. All of the cows in that class gain 20 kilogram or more. All of those in the subsequent classes gain more than 20 kilogram. So also those. The total number of them is therefore 16 plus 14 plus 2, which is equal to 32. The probability will be the total number that gain 20 kilogram or more divided by the total number of cows in the survey. So 32, those are the number of cows specified in the statement of the problem, and the total number of cows is 100. The probability is therefore equal to 32 divided by 100. Of course, we may simplify that by a common factor of 4.